Welcome, in this video we will see finding vulnerabilities with fuzz testing. Fuzz testing, or fuzzing for short, is a method for testing software input validation by feeding it intentionally malformed input. You will understand fuzzing well enough to apply the technique to uncover security issues lurking in Android operating system. First, fuzzing background. Fuzz testing has a long history and has been proven effective for finding bugs. The basic premise of fuzz testing is that you use automation to exercise as many code paths as feasible. Processing a large number of varied input cause branch conditions to be evaluated. There are many reasons why fuzzing is popular in security research community. In order to successfully fuzz a target application, 4 tasks must be accomplished. First, identifying a target, then generating inputs. After that, test case delivery, then crash monitoring. After fuzzing background, what one has to do is identifying a target. Now let's see identifying a target. Selecting a target is the first step to crafting an effective fuzzer. A few techniques that influence target selection include analyzing program complexity, ease of implementation, prior researcher experience, attack vectors and attack surfaces. After identifying a target, crafting malformed inputs. Generating inputs is a part of the fuzzing process that has the most variations. Classifying a fuzzer primarily comes down to examining the methods used to generate inputs. Each type of fuzzing has its own pros and cons and tends to yield different results. It involves dumb fuzzing and smart fuzzing. Dumb fuzzing has uncovered an extremely large number of bugs. Smart fuzzing requires applying intelligence to input generation. Fuzzing on Android. Fuzz testing on Android devices is much like fuzzing on other Linux systems. Fuzzing and software testing in general is a complex subject. Android's application of the principle of least privilege leads to various programs depending on each other. Fuzzing a program that other programs depend on can cause multiple processes to crash. Fuzzing on a live Android device is still better than fuzzing on the emulator. Now let's see fuzzing Chrome for Android. The Android browser is an attractive fuzz target for many reasons. Android browser is composed of Java, JNI, C++, and C. Because web browser focus heavily on performance, a majority of code is implemented in native languages. Browser fuzz. In that, it comes browser fuzz. This fuzzer targets the main rendering engine within the Chrome for Android browser, which is one of the underlying dependency libraries. Fuzzing the USB attack surface. Fuzzing a USB device, like other type of fuzzing, present its own set of challenges. USB devices often respond to errors by issuing a bus reset. That is, a device will disconnect itself from the host and reset itself to a default. Most applications that allow communication between two computers, applications that use USB as a transport, implement their own protocols. The last topic is fuzzing broadcast receivers. I would like to say about in brief, it involves identifying a target, generating inputs, delivering inputs, and monitoring testing. So that's all about theory on finding vulnerability with fuzz testing. Thank you for watching this video.